Alright, so this video here we're going to look at graphing quadratic functions, and you can see the two pictures that I have here. These are graphs of quadratic functions. You'll either have one that opens upward or one that opens downward. Now, there are instances where you have them open left and right, but in this video we're only looking at the ones opening up and down. The ones that open left and right, the y term is squared. The ones opening up and down, the x term is squared. Alright, so if you have one that opens upward, okay, a is positive, and one that opens downward, a is negative. Now, what is a? Well, a is the number in front of the squared term. Okay, so if a is positive, it opens up. If a is negative, it opens down. And then we have this dotted line, this vertical dotted line that goes through the vertex. That's called the axis of symmetry. And the axis of symmetry, the parabola, is a mirror image. In other words, if you go this distance from the axis of symmetry straight across to the parabola, this distance here is the same distance as if you go to the other side of the parabola. Okay, it's a mirror image. And then here we have the vertex. On a parabola that opens upward, the vertex is a minimum value, and on one that opens downward, the vertex is a maximum value. So whenever we're graphing a quadratic function, we want to find the vertex. That's the first thing you want to do. Okay, so how do we find the vertex? Well, a quadratic function, you can have it in two forms. This form here, f of x equals a times x minus h squared plus k, which we call this standard form, and then f of x equals ax squared plus bx plus c. This right here is probably what you're used to seeing. Okay, but these are the two forms. Alright, so if your quadratic function is in this form, your vertex is just hk. See, the h is here and the k is here. If your quadratic function is in this form, then your vertex for the x coordinate, see, this is your x coordinate of the vertex and this is your y coordinate of the vertex. So if it's in this form, your x coordinate is minus b over 2a, where b is the number in front of x and a is the number in front of x squared. And then your y coordinate, well, all this means is that whatever value you get when you plug b and a into here, whatever value you get for your x coordinate, you just take it and plug it back into the function to get your y value. That's all that means. Alright, so in this video we're going to do 3 examples, and all of the examples or the functions are going to be in this form. And I'll have another video where I do 3 more examples where they're all in this form. So this video is going to be in 2 parts, because if I didn't do that, it would be a pretty long video. Alright, so and I would recommend that you watch all 3 examples, because they're all going to be different. They're all going to be a little different. It's going to pretty much cover everything you're going to come across. Now the way we're going to graph them is we're going to find the vertex, and then we're going to find our intercepts, our x-intercept and our y-intercept. Alright, so if you remember, the x-intercept is this point here and here, where it crosses the x-axis. That's your x-intercept. And then this point here, where it crosses the y-axis, that's your y-intercept. Okay, and then same thing here. You've got your x-intercepts, and then you've got your y-intercept. Alright, so let's go ahead and get started graphing these things. Alright, So here's our first example. We have f of x equals x minus 2 squared minus 4. All right, so if you remember, our vertex is hk, and this function here is in the form a times x minus h squared plus k. All right, so an easy way to remember how to get the vertex, remember the vertex is hk. All right, so our vertex here is hk. All right, so that's going to be 2, negative 4. All right, so when you're looking at the formula, notice you have a minus h, and here you have a plus k. So whenever you're finding the vertex, because of the minus sign in the formula and because of the plus sign in the formula, well, your h is going to have the opposite sign of what you see, and the k is going to have the same sign. That's an easy way to remember it. Okay, so remember, h has the opposite sign, k has the same sign. All right, so there's our vertex. All right, so let me get rid of this. All right, now let's find the x and y intercepts. All right, so to find the x-intercept, the way you find the x-intercept, you take your function x minus 2 squared minus 4, and you set it equal to 0 and solve for x. Okay, that's the way you find your x-intercept. All right, so remember how to solve this. I'm going to move the 4 over, and so that's x minus 2 squared equals 4. And then I'm going to take the square root of both sides. I'm going to use the square root property. So I get x minus 2 equals plus or minus, remember the plus or minus, the square root of 4. And so that's x minus 2 equals plus or minus 2. And so x equals, I'm going to add the 2 to both sides. See, I'm adding 2 to both sides here. So that's going to be 2 plus or minus 2. Okay. All right. So now my x-intercepts are, well, 2 plus 2 is 4. All right, so the 2 plus 2 is 4. And then what did I use for my y value? Well, my y value was 0. See, I replaced the f of x with 0. So that's 4, 0. And then we have 2 minus 2, which is 0. And then once again, my y value is 0. All right, now we need to find our y-intercept. Okay, and you probably already know what the y-intercept is because of this, but let's go ahead and find it anyway. So the way that we find our y-intercept is we just evaluate this function at 0. So we just find f of 0. So that's 0 minus 2 squared minus 4. And so that's going to be negative 2 squared minus 4, which is 4 minus 4, which equals 0. Okay, so my y-intercept, well, the x-coordinate, what's x? Well, you see this x here? I replaced x with 0. So my x-coordinate is 0, and what did I get for my y? I got 0. All right, so now we have everything we need to graph it. We have the vertex, the x-intercept, and some y-intercept. So let's move this on up. Okay, let's see, my vertex is 2, negative 4. I'm going to go ahead and write it down so we can still see it when I move this up. All right, so now let's go ahead and draw our xy coordinate system. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay. So now let's just plot our points. So I'm going to plot my vertex, which is 2, -4. There's my vertex. And then I'm going to plot my x and y intercepts. So my x-intercept 4, 0, and 0, 0. Okay, and then my y-intercept is 0, 0, but I already have that point plotted. So now I can draw my parabola. Okay, and make sure when you draw your parabola, make sure you don't do this where you make it like a V, because that would be wrong. It's curved. Okay, if it's like a V, do you remember what that is? That's absolute value. Okay, so make sure you have it curved here. All right. Get rid of. All right. All right. So now let's take a look at another example. All right. So let's go ahead and find our vertex. So now let me go back to change the color. So I've got my vertex is what? -3, 5. Remember, H has the opposite sign, K has the same sign. Okay. Now let's go ahead and find our x-intercepts. Okay. So I guess I'll come up here and do it. So my x-intercept, remember, you set this equal to 0 and solve. So I have -x plus 3 squared plus 5 equals 0. So -x plus 3 squared equals -5. I'm moving the 5 over, and then I'll divide both sides by -1. So x plus 3 squared equals 5. And so x plus 3 equals plus or minus the square root of 5. And then I'm going to subtract 3 to both sides. And so I get x equals -3 plus or minus square root of 5. Alright, now, so my x-intercept, okay, my x-coordinate is -3 plus square root of 5. That's the x-coordinate. And then my y-coordinate, remember, we let f of x be 0, so I let y be 0, and so that would be 0. And my other x-intercept is -3 minus square root of 5. 0. So there's my x-intercepts. Now let's look for our y-intercept. So to find the y-intercept, we're going to plug 0 in for x. So f of 0 is -0 plus 3 squared plus 5. And so this is -3 squared. Now let me do this. Okay, plus 5. Okay, so this is going to be what? -9. All right, so this is where you got to be careful. This is not +9. The negative sign is not with the squared. See, the squared is just on this part. It's not with the negative. So this is negative, and then we have 3 squared. 3 squared is 9 with the negative in front of it. And then we have plus 5, which equals -4. So our y-intercept is, we let x be 0, and the y was -4. Alright, so our vertex was -3, 5. Let's write our y-intercept here, 0, -4. Okay, so this is our y-intercept, here's our x-intercepts, and there's our vertex. Alright, so the x-intercepts, this might be a little tough to plot here, the -3 plus square root of 5 and -3 minus square root of 5. So what you might want to do is take a calculator or something and get this as a decimal so we can kind of guess where, so we can plot this point. So I'm gonna pause the video and do that, and I'll write it down. All right, so here are these in decimal form. Okay. All right. So now it's just like the last problem. We just plot our points. All right. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. All right, so now plot the points. I've got -3, 5, which is right there. Okay. And then I have -0.760. So that's almost to -1, but not quite. So that's going to be about right in there. And then -5.24. So 1, 2, 3, 4, 5. And we'll go a little past the 5. That would be that point. And then 0, 1, 2, 3, 4. And so there's your points. So now, well, that doesn't look too good, but you get the idea. Okay. All right, so now let's take a look at this last example. We have f of x equals x minus 3 squared plus 2. All right, so let's go ahead and find our vertex. So our vertex is 3, 2. Okay. And then let's find our x-intercept. So I'm going to set this equal to 0 and solve. So I get x minus 3 squared, subtract 2 to both sides, so equals -2. And so I get x minus 3 equals plus or minus the square root of -2. And so I get x minus 3 equals plus or minus, remember this, I square root of 2. And so x equals, move the 3 over, 3 plus or minus I square root of 2. Okay, now let's look at this. We get an imaginary solution. So that means there's no x-intercepts. Okay, all right. And actually, we didn't even need to do this, did we? Look at our vertex. Our vertex is 3, 2. So if we go over 3 and up 2, our vertex is going to be right in there. And remember, the x-intercept is where the graph crosses the x-axis. Well, you see how A is positive? We know it's opening up, right? So we can see from that it's not going to cross the x-axis, so there's no x-intercepts. But just in case you didn't notice that, this is what's going to happen if there's no x-intercepts. You'll get an imaginary solution. All right. Now, let's find our y-intercept. So we just evaluate the function at 0. So that's going to be 0 minus 3 squared plus 2, which that's going to be -3 squared plus 2, which is 9 plus 2, which equals 11. So that's going to be the point 0, 11. All right, and so let's write our vertex down here. All right, so let's go ahead and plot everything. All right, so since we're not going to be plotting anything below the x-axis, I'm going to put the x-axis about right there. So I've got 1, 2, 3, 4, 1, 2, 3, 4, and I'll need to go up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so let's go ahead and plot our vertex. We've got the point 3, 2. Okay, so there's our vertex. And then let's plot our y-intercept, which is right there. Okay, now we only have 2 points, so what do we need to do? Well, if you remember how we talked about the axis of symmetry, that this thing's a mirror image? Okay, so what we're going to do is we're going to mirror the point over. Okay, so let's go ahead and draw our axis of symmetry. Okay, and let me go ahead and add some more points. Alright, so now let's mirror the point over. Okay, so if we look at this point and we go straight across to the axis of symmetry, that is 1, 2, 3 units. That point is 3 units from the axis of symmetry. So that means if we go straight across 3 more units, there's another point. So we mirrored the point. See, this point's going to be, if this point's 3 units, the point straight across is 3 units also. 1, 2, 3. Okay, and then you draw your parabola, and that's how you graph them when they're in that standard form. And like I said, you may want to watch the other video. Okay, you can see this one's already running pretty long, but I'm going to do 3 examples like this when it's in the other form. Okay, and mainly the difference is going to be finding the vertex, and when we set it equal to 0, it'll either factor or it won't. Okay, so you can watch that video, but like I said, the examples, they'll be similar to this, except it'll be in the other form. Alright, so I hope the video helped. If you like it, you can watch my other ones and subscribe. Alright, thanks.